So we want to evaluate, are the two expressions equivalent? Two ways to check to see if algebraic expressions are equivalent. You can combine like terms, or you can pick a value for the variable, substitute it into the expressions, and see if the expressions are equivalent. So I'm going to use substitution first. You can pick any value for p, just try to stay away from 0 and 1. So I'm going to use p is equivalent to 2. So I'm going to substitute 2 into both expressions for p. So my first expression is 6 times the sum of p and 5 minus the sum of 5 and p. So this is my first expression that I'm going to substitute 2 into. And then I'm going to substitute 2 into 5 times p plus 25. So I have two expressions. If I get the same value, that means the expressions are equivalent. So I'm going to write my formula for the first expression, 6 times the sum of p and 5 minus the sum of 5 and p. And then I'm going to substitute 2 into the expression for p. So instead of writing 6 times the sum of p and 5, I'm going to write 6 times the sum of 2 and 5 minus, instead of writing the sum of 5 and p, I'm going to write the sum of 5 and 2. And then I'm going to evaluate using my order operations. So parentheses first, and then exponents, and then multiplication and division from left to right, then addition and subtraction from left to right. So I'm going to evaluate my parentheses first. So I have two things that I need to evaluate in the parentheses, two sets of parentheses. So I'm going to evaluate my parentheses. 2 plus 5 is equivalent to 7. And I'm going to keep that in parentheses. And then 5 plus 2 is equivalent to 7. And I'm going to keep that in parentheses. And I'm going to bring down everything I didn't use. So this minus sign that I didn't use in the last step, and this times 6 I didn't use. So I've evaluated my parentheses. Next, I'm moving on to exponents. So this 2 is an exponent. I don't have any exponents or any powers to evaluate. So I'm going to move on to multiplication and division from left to right. So I do have multiplication here. These parentheses means multiplication. So 6 times 7 is 42. And then I'm going to bring down everything I didn't use. And now I've completed all of my multiplication and division from left to right. Now I'm on addition and subtraction from left to right. And I just have subtraction here. So I need to take 7 from 42. I need to regroup. 7 from 12 is 5. Bring down to 3. So 42 minus 7 is equivalent to 35. So now I'm going to evaluate 5 times p plus 25. If I get the same value when p is equivalent to 2, then if I get 35, that means the two expressions are equivalent. Because when p equals 2, they have the same value. And that's what equivalent means, to have the same value. So instead of writing 5 times p plus 25, I'm going to write 5 times 2 plus 25. 5 times 2 is 10, and 10 plus 25 is 35. So I still use my order operations here. Multiplication comes before addition. So since 35 is equivalent to 35, we have the same value. That means this expression is equivalent to this expression, because when p equals 2, the expressions are equivalent. So we can conclude that the expressions are equivalent because when we substitute 2 in for p, both expressions have the same value, 35. So that's one explanation. Another way is to use combining like terms. So I'm going to combine my like terms after I apply the distributive property. So my first expression, 6 times the sum of p and 5 minus 5 minus the sum of 5 and p. So for this one, I have to distribute the 6 into both parts. And then I have to distribute the minus sign into both parts. So 6 times p plus 6 times 5. So 6 times p plus 6 times 5. And then I have minus 5 minus 5 times 1. You can say, you can put a 1 right here. Negative 1 times 5 is negative 5. And then negative 1 times p is negative p. So you can think of it like that. And then we want to evaluate, so you have to remember to distribute this minus sign into both parts, not just the 5, because the sum of 5 and p, both are being subtracted from this first term. So you have to make sure you distribute that minus sign into both parts and not just the 5. So 6 times p is 6 times p, plus 6 times 5 is 30. And then we have minus 5, and we have minus p. Now you can put a 1 in front of the p so you can see what's going on, or not. So we want to find our like terms. So 6 times p, remember, in order to be considered like terms, you have to have the same exponent and the same variable. So these are both variable terms that have a variable p to the first power. So these are like terms. So I'm going to combine those. Since they have a factor that's in common, this is 6 times p, and this is minus 1 times p. I'm going to factor the p out. So I'm going to put my parentheses, 6 minus 1, the sign stays in front, and I'm going to factor out the p. So I have 6 minus 1 is 5, and then that's 5 is being multiplied by p. And then I want to combine my plus 30 minus 5. These are both constants. 30 minus 5 is equivalent to positive 25. So this is my final answer once I combine like terms and apply the distributive property and combine like terms. Notice that 5 times p plus 25 is equivalent to 5 times p plus 25. So you can also conclude that these expressions are equivalent by the distributive property and combining like terms, because once we distribute the 6 into the 2 terms inside of the parentheses and the minus sign into the 2 terms inside of the parentheses and subtract, we get an equivalent expression, because 5 times p plus 25 is equivalent to 5 times p plus 25. This one is more on the advanced level. The other one is more on the 6th grade level, where you use substitution to determine if the 2 expressions are equivalent. But whatever method works for you works for me, as long as you understand and get the right answer. All right, so let's move on to number 2. Lisa says that the expression 4 times x minus 2 times x plus 8 and 2 times the sum of x and 4 are not equivalent, because the expressions has a term that is subtracted and the other does not. Do you agree? So she said this has subtraction, so we see subtraction there. Right here we see subtraction, and then right here we have addition. So we don't have subtraction in this one. That does not mean they're not equivalent. Equivalent means specifically to have the same value. So we have to do some investigating here to see if these 2 expressions are indeed equivalent or not. So I'm going to write my first expression. I'm going to combine like terms, because I don't have to apply the distributive property, so it shouldn't be too hard here. So I'm going to find my like terms. So I have a 4 times x here and a minus 2 times x. So why are these considered like terms? Because they have the same variable x raised to the same power 1. Remember, if you don't have an exponent there, you can assume that the power is 1. So since I have 4 times x minus 2 times x, I'm going to factor out the x. So I'm going to factor out the x, put the x outside of the parentheses, I'm factoring it out, and I have 4 minus 2. 4 minus 2 is 2, and that 2 needs to be multiplied by x to maintain equivalency. So 4 xylophones minus 2 xylophones is 2 xylophones. And then the 8 does not have any like terms, so I'm just going to put plus 8. Now, is this equivalent? We have to factor out a 2, or we can apply the distributive property to see what this value is. So let's just factor out a 2. So the greatest common factor of 2 and 8, if you need to, well, 2 is a prime number. we can write the prime factorization of 2, which is equivalent to 1 times 2. And the prime factorization for 8 is 1 times 2 times 2 times 2. And then we can find the greatest common factor to see what number we need to factor out. So we have 1 times 2. So the greatest common factor of 8 and 2 is 2. So I'm going to factor out a 2, which means to put the 2 outside of the parentheses. 2 times what number will give me 2 times x? 2 times x is equivalent to 2 times x. The plus sign is going to stay the same. 2 times what number will give me 8? 2 times 2, which is 4. So I factored out the 2, and notice that it's equivalent. So this right here, 2 times x plus 8, is equivalent to 2 times the sum of x and 4. Because if you have x plus 4 twice, plus another x plus 4, x plus x is equivalent to 2x, and 4 plus 4 is equivalent to 8. So yes, if we replicate x to x, the sum of x and 4 twice, we will get 2 times x plus 4. So yes, these are equivalent. So do we agree? Absolutely not. No, the expressions are equivalent. The first expression, 4 times x minus 2 times x plus 8, can be simplified to 2 times x plus 4, which is equivalent, or which is equivalent. And remember, equivalent means to have the same value. So they both have the value of 2 times the sum of x and 4. 2 times the sum of x and 4. So that's that one right there. The next one, we want to write an equivalent expression using the greatest common factor and the distributive property. So we have to find the greatest common factor first, and we have to find the greatest common factor with variables, so this is a little different. And the distributive property. So we have, 3, and 3 times x minus 27. So I don't see a variable that's a common factor because 27 is a constant. It does not have a variable. So that means I need to see if I can factor a number out of 3 and 27. So I know that the prime factorization for 3 is equivalent to 1 times 3. And the prime factorization for 27, let's see, 3 times 9, 3 times 3. So the prime factorization for 27 is 1 times 3 times 3 times 3. So that means the greatest common factor of 3 and 27 is 1 times 3, which is 3. So I can factor out a 3. So I need to make an equivalent expression for 3 times x minus 27. I'll write that above it first. And the greatest common factor is 3, so I want to factor out a 3. 3 times what number will give me 3 times x? 3 times 1 times x, or just 3 times x. You don't have to put the 1 there. Minus 3 times what number will give me 27? That number is 3 times 3. So I like prime factorization. So 3 times 3 is 9. So 3 times 9 is equivalent to 27. So this is equivalent by the greatest common factor, 3, and the distributive property. So our answer here is 3 times x minus 9. And you can check it. Let's check to see if this is correct. 3 times x minus 9. So you would distribute the 3 back into both parts. So 3 times x is 3 times x minus 3 times 9. 3 times 9 is 27. So yes, these are equivalent by the greatest common factor and the distributive property. You just have to make sure 3 is the greatest common factor. The next one, we have to, this is the same thing. The only difference is the greatest common factor is not just 3, but both terms have a common factor x now. So the greatest common factor is going to change from just 3 to 3 times x, because we can also factor out an x because both terms have an x. So we're going to factor out 3 times x, and then we're going to write 3 times x. We have 3 times x times 1 will give you 3 times x, and then 3 times x times 9 will give you 3 times 27 times x. So that's the only difference here. And then we can check that. So 3 times x times the difference of 1 and 9. So we have 3 times x times 1, which is 3 times x. And then we have minus 3 times x times 9, which is 3 times 9. 9 groups of 3 times x is 27 times x. And we have an equivalent expression. Now the last one, you have to make sure you find the greatest common factor here. So we have 30 times a plus 45 times b. Now the greatest, we don't have any variables that's in common because our variables are different here. So we cannot factor out a variable. But we can see what is the greatest common factor of 30 and 45. No, it's not 5. So you can use prime factorization. It is 15. 2 times 15 is 30. So we can use these as 2 factors. 2 factors to make 15 are 3 and 5. So I have the prime factorization for 30, which is equivalent to 2 times 3 times 5. Now I need the prime factorization for 45. 3 times 15 will give me 45. So 3 is a prime number, so I circle it. The only factors is 1 in itself. And 2 factors to make 15 are 3 and 5. So the prime factorization for 45 is equivalent to 3 times 3 times 5. Now I can find the greatest common factor. So I have 3 times 5, which is 15. So the greatest common factor is 15. So of these two numbers, I can factor out a 15. So I'm going to put my 15 outside of the parentheses, keep my sign in the middle. 15 times what number is going to give me 30 times a? 15 times 2 times a. So 15 times 2 times a is going to give me 30 times a. So if I have 15 groups of 2 times a, that's 30 times a. So 15 times what number will give me 45 times b? 3 times b. And that is all, that is the answer right there. So the greatest common factor is 15. If you put a 5, that is wrong because 5 is not the greatest common factor. And so it's 15 times the sum of 2 times a and 3 times b. That's the final answer. And you could check it by distributing the 15 into both parts. 15 times 2 is 30 times a. 15 times 3 times b is 45 times b. And that's the answer. Write an expression that means the same as 24 less than a square of a number. So the square of a number, so a number must be squared. And then we need to take 24 less than that. So that's what you should have for that one. 9 less than twice a number. Twice a number means to replicate by 2. So twice a number and then 9 less than that. You could think of what number is 9 lower than twice a number. You have to first start with twice a number and then take 9 lower than that. The next one, 27 from a number squared. So a number squared, we don't know what that number is, so we use a variable. So a number squared needs to go first. And then we need to take 27 from the number squared. So that's what it should look like there. And then last but not least, simplify the expression. So for this one, we have to combine our like terms. So you have to know like terms must have the same variable and the same exponent. So I have 2 times m, and I have plus 4 times m. Why are these like terms? Because they have the same variable raised to the same power. So I'm going to factor out my m. Since I have 2 times m and 4 times m, I'm going to factor out the m. because m is a factor that's common for the both of the numbers. So I'm going to write 2 plus 4, and 2 plus 4 is 6 times m. And then I have plus 3 times n. A like factor with that is minus 2 times n. So I'm going to come over here and I'm going to write that. So 3 times n minus 2 times n. Make sure you keep the sign that's in front of the term. N is a common factor, so I'm going to factor out the n, and I'm going to write 3 minus 2. 3 minus 2 is 1 times n, and 1 times n is just n. And n is positive, so I'm going to put 6 times m plus n, and then I'm going to combine my constants, so I'm just going to underline this. So I have 5/8 plus, make sure you take the sign in front of it, plus 1/8. Remember, when you're adding fractions, the denominator stays the same. And then we add 5 plus 1, which is 6, the numerator. And then this can be simplified since I have two even numbers. These are both divisible by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. And this is a positive number, so I'm going to put plus 3/4. So this is my final answer right here. 6 times m plus n plus 3/4. Or you could say the sum of 6 times m and n and 3/4.